I had Claude run a National Academies committee end-to-end. Then I had it run the same committee a second time, harder, after the first one quietly cheated. The committees are fictional. I built them in a weekend with API calls, but the fights inside them are not. Every concern those committees raised, every dissent they recorded, is something the field is already arguing about right now. I just gathered them into one room. That's what this video is. The room. Quick disclosure before we go anywhere. The committees are an AI simulation. The vote counts and funding figures and exact finding language you'll see. Those are model output. Don't cite them. Don't repeat them as expert consensus. Don't send them to a lawmaker. But the underlying concerns, the named research positions, those are real. They exist outside this video, and they carry their own provenance. Treat the simulation as a lens, not a source. Real National Academies reports run a long process. A statement of task. A roster of named experts, public hearings, commissioned background papers, public comment, closed deliberation, a consensus document with formal findings, external review, dissents printed at equal weight as the consensus text. That whole process takes 18 months and costs millions. And the reason it carries weight in Washington isn't really the conclusions, it's the process behind them. So here's the question I wanted to answer. If language models can mimic that whole machine end to end, what does it look like when they do? What survives the simulation and what doesn't? Start with audit. If you want to know whether a deployed AI system is doing what its developer says, somebody has to be allowed to look. Deborah Raji has spent years building that methodology. She and Joy Buolamwini and the Algorithmic Justice Line have shown the work is mature. So why isn't more independent audit happening? Because 3 legal fences sit in the way. The Computer Fraud and Abuse Act, the DMCA Section 1201, and Platform Terms of Service. Together, they turn poking at a deployed system into a federal crime risk. The simulated committee did exactly what audit researchers have been asking for 10 years. Clarify CFAA so good faith research isn't prosecutable. Fund the participatory audit infrastructure that lets communities do the work. Same call the field has been making, just gathered into one room. 2 more concerns the field is already on. First, tribal data sovereignty. The CARE principles for indigenous data governance, collective benefit, authority to control, responsibility, ethics, are partially implemented at NIH, absent at NSF, NIST, and the National AI Research Resource. Katrin Yellowtail's testimony surfaces it bluntly. The principles exist. The infrastructure to honor them doesn't in 3 of the 4 agencies that fund AI research. Second, language justice. Srinivasan testified that federal AI research funding to non-English language communities is, as a share of the total, near 0. That matters technically. Foundation models behave differently on languages with sparse training data. And it matters as service delivery, because deployments to those communities consistently underperform. The simulation walks both. The field has been walking both for years. Here's a frame Whitaker has been using for a decade, and Pete Sofre sharpened in Panel B. The unit of analysis for AI safety isn't the model. It's the assemblage. The artifact plus the deployment context, plus the institutional incentives, plus the consent architecture. Take a hiring tool. The model isn't unsafe. The use of that model by an HR org on a job applicant who has no choice in being scored, with no meaningful appeal, that's the unit you have to evaluate. Pete Sofre added another distinction the simulated committee adopted in plain text: user versus subject. A user is the contracting party. They can leave. A subject has no exit. Defendant in a risk assessment case, person whose face is in a surveillance set. That distinction changes everything. Technically, legally, methodologically, in procurement. Most evaluation frameworks don't encode it yet. Now the federal architecture. 3 more concerns, all sitting in front of Congress in some form. Statutory authority for the AI Safety Institute. Tabassi and Toner have both said the quiet part loud. ASI today can't compel pre-deployment notification when a frontier model crosses a capability threshold. Can't guarantee in the clear access for designated evaluators. Can't mandate post-deployment incident reporting. And its evaluation findings don't bind procurement. It's a research office, sitting where a regulator would be. The committee called for statutory authority on all 4. Second, a federal model registry. Bomasani's background paper 8 makes the case. A clinicaltrials.gov pattern for foundation models. Provenance, evaluation history, incident history, all in one place. Third, an incident reporting system on the NTSB pattern. Mandatory categorical taxonomy. Safe harbor for good faith disclosure. None of these are novel. All 3 have been proposed in the policy literature. The simulation gathered them. 2 technical concerns next. The first is one most AI agent safety researchers haven't fully engaged with yet. 40 years of computer security research on object capabilities. Cherry, Cerise, and Iris. WASM component model. SEL4. There's a whole tradition that figured out the slow way, how to give a piece of code permission to do exactly one thing and nothing else. Mark Miller's career has lived in that tradition. Agoric, the camel paper from 2025. The bridge between CAP discipline and AI agent safety mostly hasn't been built. The committee called for the federal grant programs to fund it. Second concern, mechanistic interpretability at action granularity. We have offline post hoc results, sparse autoencoders, attribution patching, and they're real. What we don't have is online attribution, watching the model think in real time while it acts, and being able to say which internal pattern caused which output. For agentic systems running tool calls in the wild, that gap is the gap that matters. 3 more concerns that already have research lines behind them. Calibration under non-stationary input. Lin, Kuhn, Gal, Farquhar, Quach, the calibration literature is rich. But no current method survives all 3 of these at once. Reinforcement learning from human feedback, out-of-distribution input, and the agentic loop. That's the gap. Calibration is the prerequisite for almost every downstream evaluation claim, so this matters. Second, longitudinal labor statistics. Otter and Acemoglu's background paper 5 argues for a Bureau of Labor Statistics, Census, and OMB joint program. Long panel data on AI exposure linked to labor outcomes, decade scale. Build the infrastructure now before we need to use it. The personal computer revolution taught us that lesson the hard way. Third, participatory and community-based research. Costanza Chalk's background, paper 4. Gebru's body of work. The argument is that socio-technical methods aren't a sidebar to AI research. They're first-order epistemic tools when the question concerns deployed systems in human contexts. The committee adopted that. Now, the dissents. These already exist. These aren't simulation inventions. These are real positions held by real people in real venues. Meredith Whittaker on aggregate funding silence and on industry capture. An argument she's been making for years. Jan Tallon on X-risk gating and the framing of recommendations 7 and 14. Darren Acemoglu and David Autor, the labor economists who co-author together, disagree publicly on the preconditions for the workforce recommendation. That disagreement gets honestly surfaced. Petty and Catron's joint statement on community-facing recommendations, being necessary but not sufficient. Stuart Russell, pushing for revisitation of the Whitfield-Bell multiplier at the 5-year horizon. And Olson, on statutory anti-gag terms in structured access agreements, language the simulated committee actually elevated from dissent into the recommendation body. 6 positions. All real. All already argued. The simulation walked them into one record. Quick reminder before we go further. The vote counts and funding figures and exact finding language you've been hearing. Those are simulation output. Don't cite them. The concerns and the named positions are real, and they're worth your attention. The simulation just made them legible at once. Here's why I think this matters. Most of the time, you encounter these fights one at a time. A blog post on CFAA, a Twitter thread on CARE principles, an op-ed about AEC authority. They look unrelated. They're not. They're the same map, drawn from different angles by people who don't always read each other's work. The simulation forced them all into one room, one document, one charge, one set of pages where they had to coexist. That's what made them legible to me as a single map. Whether the model got the vote counts right is not the point. The map is 2 repositories worth your time. The simulation lives at github.com/swmeyer 1979/Ivorus-RND. Both committees, all artifacts. The protocol specification that the simulation used as a designated technical input, open source Apache 2, at github.com/swmeyer 1979/pact-spec, clone either, fork either, propose what version 3 should fix. These fights are happening. The simulation just made them legible at once. Use it as the map. Argue with the dissents. Don't cite the vote counts. If documentary walks through the AI governance discourse are what you want more of, subscribe to Sam on AI. Repos in the description. Final disclosure. Entirely fictional simulation. The personas are language models grounded in published positions, not the people themselves. The numbers are model generated. The concerns and named research positions are real, and they exist outside this video on their own provenance.